Hi, everybody. It gives me a great pleasure to introduce to you the moderator for the panel coming up, which is Enabling Additive Manufacturing with Carbon Fiber and Composites. The moderator today is the famous Tuan TranPham, with Chief Revenue Officer of Arevo. Tuan has spent 16 years working for 6 of the largest 3D printing companies such as Z Corp, 3D Systems, Objet, Stratasys, Arcam, which is now a GE company, and Desktop Metal. Many of you, I'm sure, know Tuan. Tuan possesses a unique perspective and insight on 3D printing applications and challenges, opportunities, technologies, and trends. Tuan is extensively connected with the 3D printing industry and has over 19,000 LinkedIn followers, which I'm sure many of you know this. He was recently presented a Distinguished Innovator Operators Award known as the Dynamo Award within the 3D printing industry. Tuan business engineering degree from the Danish Technical University and gained experience while working in Denmark, Hong Kong, Japan, and the United States. He speaks Danish, English, and Vietnamese. Tuan is based in Greater Boston area where he lives with his wife, Thao, and his son, Sebastien. Tuan, take it from here.
Excellent, Angie. Can I share that one slide, or can you show that one slide for me?
Sure.
Can you switch over to?
Or you, if you have it up quicker, it might be faster for you two right now.
Okay, let me try application window.
Because I think I get extracted out.
Okay, Janet is on. The next slide, Janet.
Here.
Okay. Give me 1 second. I can't seem to be playing that 1 second, but never mind. Thanks, Angie. I'm super excited to be moderating this Composites panel, and which we hope will be both educational and inspiring how to get started with composites. What we hope to address the next 45 minutes is questions that you might have, such as who are the players in composite? What are the different print engines that exist, and how do they differ? And how is composites used today? And what could it be used for? So opportunities and challenges that we see and where it's going. But before diving into the 5 sections of this composites panel, for these 5 sections, I want to have my panelists introduce themselves, 2 minutes each. Let's start with Martin, then Fedor, and Konstantine. Please introduce yourself. Thank you.
Thank you, Tuan. Thanks, everyone, for listening. I'm really excited to be here. It's also for me my first digital conference. For us, it's now close to 12 at night, but it's really exciting to have like a full day conferencing. Also like being connected to all the guys in the US as well. So to myself, my name is Martin Eichenhofer and Labs. So we are a 3D printing company solely focused on fiber composite materials here in Switzerland, so in the heart of Europe. To myself, I'm by training a composite engineer and I'm an aerospace engineer as well. So for the last over 6 years, I have been just dealing with additive manufacturing and fiber composites. So basically from the very details on the materials, so really on the chemical side, all the way to kind of like business cases, towards more like kind of like gearing the technology towards series production. I was like really focusing a lot during my PhD on what does it really take to push a technology like 3D printing of composites with continuous fibers into the series production space. So this is really like kind of like what 90 Labs is also focusing on. And what I don't want to take more time. So I want to hand over. Tuan, you give it to someone else, or I give it to someone?
Fedor?
Yes, thanks, Tuan. Thanks, Martin. Hello, everyone. My name is Fedor Antonov. I'm CEO and one of the founders of Anisoprint. We are one of the players here in the composites additive manufacturing landscape with a focus on bringing the most flexible composite manufacturing technology that is possible. So this is our our main vision and our main goal to enable the composites in the applications that they were not present before, and to replace less efficient materials with a much more superior and much more efficient composite materials. My personal background is in mechanics, in fundamental mechanics of solid media. So I have a PhD from Moscow State University in mechanics of deformable solids. And I worked both for industry and for academia doing design and optimization of composite materials and structures. So I have a strong background in optimizing the composite materials. So do my co-founders. And we have a common vision of how to design and to optimize with the composite materials. So that's where we want to be in future, yeah, to bring composites into new applications and new fields. Thanks, Konstantine.
Thank you, Fedor. Hey, everybody. My name is Constantine Fetfatsidis. Say that 5 times fast. But so I currently head up the Composites products division at Desktop Metal. Been in the composites area for probably close to 15 years now, across a wide variety of applications ranging from automotive to wind energy to aerospace, and design, analysis, manufacturing, and testing of composites. My most recent experience was with a company called Aurora Flight Sciences, which is now a Boeing company. The manufacturing R&D there. And from that, I decided to go off on my own and started a company called Make Composites, which was the goal was to develop a low-cost printer that could leverage a lot of the high strength and stiffness properties that continuous fiber materials had to offer. And that was brought into Desktop Metal last summer, and then we launched our fiber printer in November. So I'm currently there as a result of the acquisition.
Thank you, Konstantin. For this panel, the next 40 minutes, we'll be using Janet's window, the Composites landscape, as a reference tool for this panel discussions. There are our emails is also on this slide, so you can have follow-up questions and you can engage with the individual manufacturer after this panel. The 5 sections we want to be covering is the landscape and demystifying the myth of what's the best way to get started with composite. We'll be talking about applications and obstacles and challenges and opportunities in this space. But before we get started, what is composite? So often you will find composite 3D printing. You have been familiar with plastic and metal for a long time, for decades, but where you often will find composite is often between plastic and metal. And depending on the geometry, in most cases, you will find that depending on the geometry, that composite parts can be even 5 times stronger than even titanium at 1/3 of the weight. So at a much affordable entry point. So it can be very compelling to do so. But within composite, I've here on the top left written some few taglines of different areas of composite that we might be touching. So these are the tag words that we might be using. But within composite, we have here done a rough illustration of the industry, the compositive landscape, looking at applications and looking at size. But you can slice and dice it in many different ways. But roughly within the composite, there are many different ways of using composite. And here in this illustration that we put together, you will find there are at least 5 and more coming, at least 5 different print engine technology. And my industry friends, Desktop Metal with the fiber, Anisoprint, and Intelab are all within the space of FFF, FDM with extrusion. A very good definition. If you want to look at something even bigger, mid-size to large size, from a soccer ball to a bike frame, you often need to go to a robotic approach, DED, direct energy deposition, where you will find companies like Arevo. If you want to go even bigger than that, building a whole boat or a blade for a wind turbine, you might go to big area additive manufacturing, and these are those players. We have other technology using LUM, like impossible objects, or Fortify using DLP. So these are the 5 most relevant print engine technology within composite, and they each have their strengths and weaknesses. So let's dive into it. So let's talk about benefits of composite in short. What are the benefits with composites? Martin, do you want to take that one? You need to unmute first. Yep.
Okay. So I was just saying, like, usually what hits people first, or when they think about composites, fiber composites in particular, it's about the strength of the materials. And then they also look at the density, and then they see, okay, as you already mentioned, the low density, the high strength. So it's a lot about the specific properties of the material. And that's kind of like one of the opening points for always like talking about lightweighting. But I want to emphasize that there are more unique features to this kind of material. And that's also like being like X-ray neutral, like for medtech application could be really valuable, or having like a low coefficient of thermal expansion. And that's really really important for severe environments, for a telescope, for instance. And also being like really chemically resistant, stuff like this. So there's actually much more than being just lightweight.
But getting started with composite, you have often been at trade show, and you often get questions, how do I get started with composite? Regarding demystifying some of these myths, Constantine, do you want to have a thought on what is the right way of thinking of composite when engaging with composites?
Yeah, I think in general, traditionally composites have been very highly skilled, specialized type of industry. There's a lot of infrastructure set up, a lot of square footage, big expensive autoclaves, a lot of expensive mold tools, the materials, they have to be stored appropriately. There's just a lot of different process steps and a lot of manual labor involved that has made it really difficult for newbies to step in and be able to address or to be able to apply, I should say. So I think one of the ways that additive has come to the forefront here to make it more all is that it's allowed people who've never laid up a composite part by hand the ability now to consider composites, continuous fiber more specifically, in designs where, first and foremost, you probably are looking for a way to lightweight a structure that may have otherwise been metallic. But there could be, as Martin mentioned, other reasons. For example, you may have 2 components going together and you're concerned about the coefficient of thermal expansion. You have some corrosive applications and you're worried about the corrosion resistance of the part. So now, without having that highly specialized background or the facilities and the infrastructure in place, you're able to leverage a lot of these additive systems in the comfort of your office or even your home in many cases, to be able to start getting involved and understanding how to print with this material.
Excellent. Fedor, Martin, do you have any comments on advices on how the best way to get started with composite with the right mindset?
Yeah, I think I can add something here. First, I want to add something to your first question, which Martin answered. I think it's really important about that they allow to tailor the material properties. So this is the type of the material which is born within the structure, but not as we normally used to think, when we have material and then we bring it in, with its properties, and then we shape it and bring it into structure. With composites, it's all the same. Yeah. So the is born inside the structure, and the material properties can be tailored to the structure. And with this, you can optimize not only the shape of the part, but also the internal structure and the properties of the material. So this is a very important point about composites to understand. So it's they offer another base for optimization, which is the material properties, which can be different in every material point, which can be which can match the loading conditions and the internal forces in every material. So I think it is really important to add what's so specific about the composites. Now to your second question, which Konstantin answered, I think that we are now so the composites are there for half a century, yeah. So where people work with composites and they used to think of composites as of composite structures and of composites parts as a set of parts. And if you would talk to someone, if you would ask someone what type of parts you would make composites, people would start talking about large thin wall structures or profiles or cylinders, something like that. So far the existing manufacturing technologies, they have these type of limitations which do not allow to make like real shape, intricate shape structures. And so this is where I think traditional composite technologies have significant limitations which do not allow to go into wider applications.
Very good. In terms of application,
can I just quickly add one point, Juan? Because it's really like what Fedor said is really, I think, an important part. And I get actually this question a lot, but from a different perspective, actually from the people that know about the metal side. And a lot of, in many cases, like the mindset is similar that, okay, we can manufacture pretty much every like super detailed structure we see in metal, also with composites, especially for the continuous fiber composites. And that's actually not true. And so it's really important to understand, like, okay, as Fedor said, we have like this capability of tailoring the fibers inside, but being just the mere fact that we are using fibers, continuous fibers, also imposes a limitation. And the limitation you have to understand to identify the real applications. And you know, there are applications for metal 3D printing and there are applications for composite 3D printing. And I think this is really important to understand this kind of differentiation on the application side.
excellent point. But it also sounds to me like a little bit of evolutions. Composite is younger than metal 3D printing. So if we look at back in time when we went from subtractive metal to additive metal, it was a change of mindset. And what I also experience sometimes is like a question of, these are the parts I do isotropically in metals, in the part of it fusion. Can you do this part in composite? Not understanding that with continuous carbon fiber or carbon fiber, where you have anisotropic properties, that your design freedom and constraint are different than metals. So it seems to me that for composite, there are more and greater need for design for additive for fiber placement. Does that make sense?
Yeah, I could take that one first, I guess. Absolutely. No, that is by far the number one, especially for people just getting started. They probably had some prior experience printing or manufacturing plastics or metals. And a lot of those materials, not all of them, are generally isotropic, right? So then they have a metal design, for example, and the belief is to take that same design and build it. Well, to Fedor's point earlier, you know, your fibers, you know, your maximum properties are going to be along the direction of your fibers. So you can actually use that to tailor your structure so that, you know, you're really only putting the stiffness in the area that you actually need it. And so that changes the design that you might otherwise had with a fully isotropic material like a metal. And so I think sometimes you see people in designs where they have cutouts, pockets that have been machined out, and they've done that for weight reduction. Well, if I go from steel to carbon fiber, I'm already reducing my weight by, a fifth. So I don't need those pockets necessarily. I might want to design it a little bit differently to actually maximize the use of my continuous fiber to get the maximum stiffness I can get in that particular orientation, right? So there's a few different design philosophies that need to be adopted or understood. Once you understand the benefit of the continuous fiber, and you start to understand how you can design to its strengths, it changes the design of the composite part from what otherwise might have been, an isotropic metal design.
Thanks for that. In the third section about applications using composites today, too often do we hear about is composites being used for jigs and fixtures and end effectors, but can you inspire the audience? What are the other applications that composites can also be used for? Who want to take that first?
Let me take that. Yeah. First, I want to know that I've actually lost this the sound from Martin and Constantine. I could only hear you, Tuan. So it's a pity. I hope that's only for me and not for the audience. But I've just seen in the general chat that someone else was complaining. So I would ask organizers to check if it works for everyone. As for the applications, obviously we are in the very beginning of the technology development and of the technology maturity. So we still have to find applications in the verticals where we do not face a strict certification, and we do not face large volume production. So we, as in the most, mostly in 3D, we have to start with certain applications where the barriers, these big barriers such as productivity and certification, are not relevant. So if you start looking into such applications, but obviously, these are not the potential applications. So the potential is exactly to go in the end-use load-bearing weighting for end-use parts in like aerospace and automotive and so on. But so far, while it's still in our bright future of composite 3D, these smaller segments which we can start with, where we can start implementing that technology, are basically the ones that do requires these strict measures. So it's tool jig and fixtures, it's function typing. So it's manufacturing of prototypes that are not only like visual or assemblers, but to really test the functionality, the proof of concept of the products and of the. And then when this phase is over, one can switch to a more productive technology that requires significant investments in the manufacturing establishment. And then it's spare parts, certain spare parts which can be easily replaced on site in a service bureau or in a manufacturing facility to replace certain parts that need a complicated manufacturing setup. So these are the simple thing.
Awesome. So try to give your answers about 2-3 minutes to have time for our panelists. Martin, do you want to expand on that?
Yeah, great. Thanks, Fedor. I think I tend to disagree a little bit on what Fedor said, but I think he was already expecting me saying this, because I think actually the time is ready to go from just the production domain into the series production, or for me, the real manufacturing, so to say, domain. for series production, so higher volumes, certification processes. And I think we are ready, but we don't have to be just focused on 3D printing, because I mean, sometimes it's hybrid processes, it could be post processes, and I'm actually really convinced, and that's also a philosophy at 90 Labs, that we have to expand just 3D printing and pair it with post-processing technologies that really enables us to go into series production. So we get the quality, we get the reproducibility, the traceability, and we are there. I mean, it's just a matter of really like rolling it out to the applications and really going through the certification process. But I think technologies are ready, but we just we shouldn't just focus on in situ printing, which is just a mere printing and ready to use part. We should really expand on the technologies.
Excellent. Konstantine, do you have anything to add?
Yeah, I tend to agree a lot with what Martin said there. If you consider composites today, it's already a multi-step process that requires it's not just a single step. So the potential to have an automated laydown technique where you're replacing a lot of manual labor that's handling parts into a mold today. It doesn't have to be the full solution, but it can certainly be a part of the overall cycle that helps reduce costs significantly, improve repeatability, improve quality, and help get part cost down in general. As a perspective, the overall composites manufacturing landscape today, additive probably accounts for less than 0.1% of all the parts right now. So they're very hungry for a solution that'll work, but there's also a huge commitment, particularly in industries like aerospace, to qualify and to certify new materials, new processes, right? And I think part of the barrier is just that, right? You have to be able to demonstrate equivalency, go through a bunch of certification tests and make sure that the properties you get are meet a certain threshold. Once people start to get more access to these systems and start using it, you've seen it sort of break through. The lower hanging fruit has been in tooling. So a lot of these aerospace users, for example, are starting to use additive for tooling, but they're still hand-laying the composites over the tool and then putting it in the oven to cure it and all that. So I think we're breaking through, as Martin was saying. It's there. It's just a matter of kind of educating the public about what the capabilities are, and I think it's only a matter of time here in the next decade that we'll start seeing some breakthroughs in production.
Tuan, can I have a bit of a discussion here, because I will allow myself not to agree with Martin at some point, because I think that the main value that 3D printing brings is a flexibility in many ways. So the flexibility to make complex shapes, the flexibility to run the production and to change it without changing, and the tooling. So for my point of view, it's really important, if we're in the 3D, that we have all these flexibilities that that it brings. So in most of the cases, post-processing will require molds and a certain complex, and all these secondary steps will complicate the process, and we will lose most of the benefits that we would normally want to have in a 3D. So of course, that's a bit of a different approach. So and I'm sure that both have its pros and cons, but from our standing points, it's really important to keep all these flexibilities available for the customers.
Excellent. What I'm trying to gather from this is also, we draw the analogy to metal 3D printing. Well, metal 3D printing has been around for 25 years, but 10 years ago, it was mainly just for prototyping, just for functional fit form, was just for prototyping. But then the last 5 years, you're starting to see short production runs, spare parts, and even GE buying Arcam and Composites and do low pressure turbine blade in high volumes of hundreds of parts. So it sounds to me like in composite, we are growing up already today, you can find hundreds of carbon fiber bike frames and e-bike being printed today. And slowly and surely, you will also find tennis racket being done via 3D printing using continuous carbon fiber. So I think we are in the stage, I would say, carbon fiber is growing up, and this is where we are expanding the application, I guess, with machine reliability, repeatability. It is graduating and expanding the application so that we can go into FAA regulated verticals and so forth. That was about application. To this panel, what are the key obstacles you see that is preventing composites to grow even further? My first point would be not enough people know about composites. So knowledge of composite, I think, is an obstacle for us composite friends, how to leverage composite more. But besides that, what are the other obstacles that you see for composite to grow? Constantine, do you want to start with that one?
Yeah, sure. I think a big one, and it's related to the knowledge, but it's more from the design knowledge, right? It's one thing to not necessarily understand what composites are, but people can learn that and say, okay, I understand that it's stiffer along the fiber, et cetera. But now how do I design it and analyze my structure to understand what my stresses are going to be within each stand, as my interlaminar strength and things like that. So there's design tools out there that, finite element analysis packages that are commercially available or very developed, in-house developed codes even that all kinds of different tools. But I think getting people to utilize them and understand how to take advantage of those tools to really help them design optimized composite structures. I see it right now that there's still an obstacle there, right? I think, and that's what drives a lot of the design to be what we call quasi-isotropic. I think people basically generate something that we've called black aluminum in the industry, where they'll take a metal design and they'll just do 0 degrees, 90s, plus minus 45, and just lay that up over and over again to get something that's lighter weight than the aluminum part. But in reality, if you truly are going to tailor your part and take advantage of the anisotropy, you really need to be able to understand how to design, and that requires some knowledge of the ability to analyze the stresses and the strains. And I think there's a lot of variability in the analysis packages today that the accuracy in what you actually get there in stresses and strains can vary pretty significantly, much more than in the metal world, for example. And so what you end up doing is then you end up adding a significant safety factor on top of that to overcompensate for something that you may not trust. And then you're unnecessarily increasing weight and you're not truly optimizing the part. So I see that as a huge obstacle in composites in general, not just in 3D printing. I think that design and analysis is definitely a lot of room for improvement there.
Thank you. Do you want to add anything to that? Or do you see software to be one of the main challenges?
Mm-hmm. I actually completely agree with Konstantin, everything he said. And I just want to a little bit expand on the processing side, because at the moment, what I see really is limiting the entire space, that at the moment, if you want to make a part out of any material and you have the full choice, there's composite materials, there's metal materials, you know about them. It's actually not so much a fair, it's not so fair to, for you to which one to choose, because the knowledge about, and that's what you mentioned before, about composites is quite limited. It's really specific space. And also the processing technologies, they are quite complex. They are really, not so many people really control the entire workflow from really going from an idea to an end-use part. Not so many people actually have the full capabilities in-house, being really able from an idea to kind of materialize the idea. And that's, I think for me, it's one of the biggest limitations, is that we have to make this technology, the technologies for composites, as accessible as the metal manufacturing technologies. If we get it to the same level, then it's not so much a choice about the manufacturing technologies, it's a choice about the materials. What's the right material for the application? And we have to get to that level. And on the composite side, there is like a big way to go on making processes, the workflow as accessible or as easy to use for everyone out there than the CNC metal manufacturing.
Thank you, Martin. Fedor, do you want to...
Exactly. Yeah. If you allow me, sorry. Exactly. So composites, actually, the thing is that composites are much more complex by nature. So everything with what you want to do with composites, either it's a simulation or design or manufacturing, it will have another level of complexity compared to more simple materials, like metals. So and this is about what Constantine and Martin mentioned, but also with composites, you need to manage the material properties. You need to be able to go from a design space, from your design to your actual manufacturing stage. So to be able to derive your tool path from your CAD or FEA analysis, and I think this is the problem that is not solved because if it's layer by layer, as we have in a laser 3D or in a simple FDM machines, that then it's much easier to get this tool path for manufacturing. But with composites, when you really need to be able to place the fiber in the right three-dimensional direction in every material point, then this process of generating the tool path is much more complicated. You need to go to a 3D, to a real 3D space. And this is a big challenge, a big, I think, mathematical problem that is not yet even stated properly. So I think this is where I see the biggest challenge and the biggest obstacle is to go from 2D to real 3D in terms of computer-aided manufacturing and tool path generation.
So if 3D printing is really the triangle of hardware, software, materials, and logging in that process, we talked a lot about the software, but let's talk about materials. Is the limited amount of composite material availability, or because manufacturers have a closed loop system or open material loop system, is that one of the obstacles for the industry to grow faster? Is it because there's not enough composite material or big enough supply chain, or is it because they need to be open before composite can grow even faster? We want to take that one about material, close, open.
I could take a quick crack at that. I think if anything, there's too many options right now, and that's part of the problem. You can combine carbon fiber with different thermosets and different thermoplastics and fiberglass and Kevlar and fibers, and there's so many different length scales involved, right? You're talking about the length scale of the individual filaments of the fibers that make up the toe, right? So there's the microscopic scale, the mesoscopic scale, and then the macroscopic, and the ability to predict all of those properties at different scales and to have uniformity across all those materials is a big challenge. I think that's part of the problem with the material. I think if we can all, if we can make the same set of materials more repeatedly, like when you make 6061 aluminum, there's very little variability between one supplier 6061 and another supplier 6061. But in composites, you have so many different suppliers making, 12K toe carbon fiber, 24K toe, 3K toe, standard modulus, intermediate modulus, high modulus. So much variability that it makes it really hard to really. It's like going to a vending machine and having a million different options. Which snack do I pick, right? But that's kind of how I see it.
Martin, you want to?
Yeah, I also agree. Well, I just want to add, I mean, it's actually a lot about the supply chain as well. I mean, sourcing this kind of materials, if you looked into the space, it's actually not easy. So if you're just like someone looking into the space, hey, I want to get some material, some samples, you would be surprised how many pages of paper you have to sign first, right? So it's a little bit different game compared to the conventional, like just need plastic field. And that's why we also don't see so much like makers working with this kind of material. For one, it's too expensive. Second, the supply chain, the sourcing is really hard. So this kind of limits a little bit the momentum we can generate for this entire space. Obviously, other commercial companies, a lot of them are also offering the materials, and sometimes they are linked to the printers itself. So you know, this is kind of it's a little bit limiting the space itself, you know, to blow up. So that's why what I wanted to add. And this, I think, it will not change soon because all those material suppliers, I mean, they will not change in the next couple of years. So this will be still quite a limiting factor to this entire field.
Okay, so Fedor, with 3 minutes left, I want to have one more time.
Yeah, sure.
With 3 minutes left. So it sounds to me like material is not as big a concern as software, meaning optimizing the design using FEA analysis, simulation, fiber placement is a bigger requirement for composite to really take advantage of composite. So if we agree on that, then my next question for this panel is that a manufacturer's of 3D printers' responsibility to enable all these software modules, besides just slicing the file, to optimize whatever design you have for composite, or is it the customer themselves, which will take longer if they have to go buy a generative topology optimization software from vendor A, FEA analysis from vendor B, using the slicing from the 3D printing hardware. It seems to me, is that the manufacturer's responsibility of a 3D printer to enable all those software modules to be integrated? What are your thoughts on that?
I can go quickly first, but is Fedor still like, oh yeah, he's coming back. Maybe he should go first.
I think I've missed the last part of your question, but I got the first one. Sometimes I don't know that the channel is frozen. Yeah, I think that it can go both ways. Of course, we have strong software companies that are in the business for many years, and they know how to do simulation. They know how to do this kind of stuff. But obviously, every OEM, yeah, he knows better his technology, the capabilities of the machine, and the limitations of the technology, and the limitations, you know, of the machine and the materials. So the software that he would develop would fit better his technology. But I think that, of course, in most of the cases, the resources and the experience and the knowledge belongs to these guys who are in the topic for many years. So I think that the best solution here is to go to partnerships and collaborations, and this is like, it's a really interesting topic, and we understand that software will be really enabling these technologies in future. So it would be a benefit, I think, for everyone, for both the software companies and the machine OEMs, to go into such projects, collaborations, to bring the software, which will have the hardware that would work for that software, and the software would enable certain complex design and optimization for this particular hardware technology.
Great. Martin and Konstantin, do you want to add?
Yeah, I was just going to say, I think it is the manufacturer's responsibility to integrate into the workflow. I don't know if they necessarily need that software. Like I said, there's a lot of different people out there who develop design simulation software, but I do think you don't want the user to have to go necessarily outside the workflow to go do an analysis somewhere else and come back in. In the same way, we've generalized the CAD, and it doesn't really matter what package you're using the CAD to make the geometry. As long as you export it as an STL or whatever format, you can bring it into your slicing software. Along those same lines, there should be some analysis in that workflow that is integrated, and that becomes the manufacturer's responsibility. But who actually develops the software? It's a call to everybody to to help develop that.
Excellent.
I just agree. Integration is really key point here. We have to have fully integrated work.
Thank you so much for your time. I think Janet is about to.
Thank you very much for everyone participating in the panel. We really appreciate your time. If you guys have any questions, feel free to reach out to them at their virtual tables.